Well, hello everybody. Hey, what I need to do with you today is I need to cover day 1 in chapter 3. It's called the Graph Transformation Theorem. What you need to have in front of you would be the day 1 notes. Don't panic that there's a staple in there. I don't plan on going over every example in there. If I do, it's going to be about a 45-minute video. I really don't want it to be that long, so I'm going to get enough information in you that you'll understand what's going on. You'll also need a purple note card. If you do not have a purple note card, I should have just some paper copies of it until we can get some more purple note cards down. But here's what I'd like to start with you first. Before I jump right into the video, I'd like to remind you what happens when we work with the graph. And when I say work with the graph, I mean translate it, move it left or right, vertically stretch it, make it skinnier, vertically compress it, make it wider. So this is a unit that you've done in Algebra 2, but I just want to remind you of a few things. So I decided to pick on the graph of y equals x squared. Notice what happens when I put something in parentheses. Notice that moved my graph 3 units to the left. Notice that I put a +3 inside the parentheses, but it moved it to the left. Now, notice what happens when I put a -5 in the end. We'll say that this graph has been translated 3 units to the left and 5 units down. When something's in a grouping symbol, whether it's parentheses, under the square root symbol, within absolute values, it'll always move it left or right, opposite of what you think. Now, I'm also going to pick on this again. Notice what happens to my graph when I put a number in front of there that's greater than 1. Notice it made the graph skinnier. Well, instead of calling it skinnier, we call that vertically stretched. If the number's smaller, between 0 and 1, notice that it's going to make it, if I can type it in right, let's just call that 0.3. Notice that made it wider. What we'll call that is vertically compressed. Now, you'll also run into this as we go today. I'm going to come back with that x minus 2 quantity squared minus 5, the one that we had earlier. Watch what happens, though, when I put a negative in front of the x. Notice that it reflected it over the y-axis. Notice what happens if that negative happens to be out front, though. Notice it reflected it then over the x-axis. The other one, once inside here, reflected over the y-axis. So that's just some real quick review on that. Now, if you would, come over to your note sheet, and let's see what you do or don't remember. Now, I made up a couple examples just to show you that these are not on the notes yet. But if you have the equation f of x equal x minus 3 quantity squared minus 7, that's going to be the graph of a parabola. And we're going to say that it's been translated, so I'm going to put a capital T there, 3 units to the right and down 7. Now guys, what that means is that every x-coordinate will be added by 3, every y-coordinate will be subtracted by 7. Now, as a rule, it would look like this. You'll see a capital T parentheses xy. What we do next is tell the world what's happening to each point. So every x value is going to be added by 3. Every y value will be subtracted by 7. Now this is not your number 1. It's very, very similar. I'll come to your number 1 here in a second. My second one here, this graph has been translated 7 units to the left and down 5. When I write the rule for it, what it means that every x value will be decreased by 7. Every y value will be decreased by 5. This is what our rule will look like. Along the way, we'll call it a translation. This one, I'm not sure what the graph looks like, but I do know this. The translation will be 7 units to the left and 9 units up. When I write the rule for it, every x-coordinate will be decreased by 7. Every y-coordinate will be increased by 9. So if you would, come over to your number 1. Consider the equation y equal x minus 3 plus 7. What's the translation rule? What we do is we tell the world what's happening there. If I use the capital T, every point's been moved 3 units to the right and up 7. My rule will look like this then. Every x value has been increased by 3. Every y value has been increased by 7. So that's what the rule looks like. On my number 2, I'm given the rule, and I'm asked to apply this to the graph of y equal x cubed. Well, in terms of a translation, if you have an x plus 4, you got to think backwards. What's got to be in your equation so that every x value would be added by 4? Well, it would have had to been a minus 4 in there. And then every y value would have had to been by a minus 3. So when I write this as an equation, it's going to look like this. I need my parentheses with my cube. To get every x value increased by 4, there must have been an x minus 4. Every y value to be decreased by 3 would look like that. So there's the first couple. Here's my number 3. They're giving us the translation rule. They would like for us to add 8 to every x coordinate, subtract 10 by every y coordinate, apply it to this parent function. Well, it's going to look like this. F of x is going to be, to add 8 to every x coordinate, there must have been a minus 8 within the absolute values. And then to move everything down 10, would it look like that? Same thing with your number 4. Write the rule for this translation. Well, every point here, that minus 3 is going to move my graph over 3 units, and then it's going to move it down 5. So the translation rule will look like this. Every point, the x coordinates have been increased by 3. Every y coordinate decreased by 5. So there's our first 4. Now, if you would, grab your calculator, and we're going to graph y equal 1 over x. And as you do that, guys, it's going to look something like this. That's the parent function of y equal 1 over x. Now, don't do that to your graph, though. What we're going to do is a new graph, though. Write the graph of the parent function, y equal 1 over x, that has been translated 3 units to the left. So to translate something to the left, I need to see an x plus. In this case, 3. And then 4 units down. Well, here's what this new equation looks like. Y equal 1 over x plus 3 minus 4. That plus 3 moves it 3 to the left. That minus 4 will move it down. Give the equations of the asymptotes. Guys, originally my asymptotes were at x equals 0 and y equals 0. That's when there was that graph. Well, think of what we're doing. We're moving that 3 units to the left. So my vertical asymptote will now be x equal negative 3. My horizontal asymptote will now be y equal negative 4. Now, I'm going to go ahead and draw those in real fast. I'm going to go ahead and count by 2s. I'm going to count 10, negative 10. I'm going to count by 2s here also. I'm going to draw a vertical asymptote at x equal negative 3, which will be right there. Now I'm going to draw a horizontal at y equal negative 4. Now, you can use your calculator now, if you'd like, to grab a few additional points. Make sure you know how to type that in correctly. So once my calculator pops up here, we'll get that typed in. So I'm going to clear out anything I have. I'm going to make sure my stat plots are off so my graph doesn't get messed up. And to type this in correctly, guys, it's going to look like this. 1 divided by, I need that x plus 3 as a group. and then I can go minus 4. Now, once we hit graph, I'm going to zoom 6 this so it fits nicely. There's what my new graph should look like. Notice that it looks like it has a vertical asymptote right there at -3 and a horizontal right there at y equal -4. Now to sketch this, we need a couple of points. So let's go trace 0. So I'm going to graph the ordered pair 0, -3.666. So 0, -3.666, so I'm right there. I might also go trace something in here, maybe trace -1. And there I get -3.5. So -1, -3.5. So that's enough to help me out on this branch. I know this branch is going to go like this. Now let's get that other branch. My vertical asymptote is at x equal -3. Pick a number to the left of that. So let's go trace -4. So it looks like I have -4, -5. -4, -5. So I'm going to be right there. Now I am going to come back and label these. There's -4, -5. This was 0 and -3.6 approximately. And then this one happened to be -1, I forgot what that was. -1, -3.5. So there's our graph so far, guys. Notice that every branch has a point. I've got my scale, and I've drawn my asymptotes using dotted lines. Now the domain of this, the domain uses every x value except for that -3. So my domain will be -infinity to -3, along with -3 to infinity. Fancy way of saying everything but -3. My range will use everything except for that horizontal asymptote. So -infinity to -4, along with -4 to infinity. So there's a graph. That's the only one that we're going to graph on these class examples. Now, you should have a purple note card in front of you, or at least one of those printed sheets off that I would have left there for you. Now, there's a special order that we would like to consider when we talk about these graph transformations. And when we say transformation, we mean a translation, left or right, a reflection, flipped over the x, flipped over the y, or a dilation, horizontally, vertically stretched. So if we think about number 6 here, when we look at the directions, identify the parent function. Well, in this case, the parent function is going to be the absolute value of x. That's the parent function. Now, we're going to go down this list in this order, and then that'll help us properly describe this. And then, of course, we write it as a sentence. So, guys, it starts looking like this. First thing you ask yourself, has it been reflected over the x-axis? If there's a negative out front, it has. So what I'm going to do is I'm going to put a 1 and a 2 and a 3 and a 4. The 1 representing the reflections, a 2 representing the translations, the 3 and 4 representing the dilations, and then the other reflections. So let's just go down that list. Is there a negative number out front? The answer is no. So there's no reflection over the x. Ask yourself now, has there been a translation? Well, there has. So I'm going to go, there's a translation, that's 1 to the left and up 7. I'm going to look for any dilations, any number out front, or any number directly in front of the x. In this case, there's none. Now I'm going to ask myself, has it been reflected over the y-axis? Is there a negative inside the grouping symbol with the x? And in this case, no. Now, to write my sentence in, the graph of y equal the absolute value of x has been translated, and we just tell the world what happened. 1 unit left, and 7 units up. That's going to be our steps on these, guys. We're just going to look at it, write down our 1, 2, 3, 4, and then everyone will have a sentence that looks something like that. So here comes your number 7. If you would, put a 1, 2, 3, 4. And let's just go down that list. Has it been reflected over the x-axis? In this case, yes. It's been reflected over the x-axis. And while I'm here, the parent function was our cubic graph, y equals x cubed. So it's been reflected over the x. Has there been a translation, a movement left or right? So I'm going to go capital T. There's no grouping symbol with the x, so it's going to go 0 units left or right, but it's going to go down 4. So there's my translation. I'm going to ask myself if there are any dilations, any stretches, any compressions, and there's no number in front there, so there has been none. And then we're going to ask ourselves, has it been reflected over the y-axis? In this case, the answer is no. The reason being, there's not a negative inside a grouping symbol with the x. This out here we already used when we said it was reflected over the x. Now, our sentence then will look just like this. The graph of y equals x cubed has been reflected over the x-axis and translated 4 units down. So that'll be what our sentence will look like. I'll give you a second to write that down since I cheated and I typed it up. But we just list our 1, 2, 3, 4, and then we go. The next one I'm going to jump over to is number 9. I'm going to jump over to number 9 next. So if you need, just pause that video if you need to write the sentence down. So here goes our number 9. Let's go 1, 2, 3, 4. And let's just go down the checklist. Has it been reflected over the x-axis? The answer in this case will be no, because there's no negative out here. While I'm here, the parent function is going to be y equals x squared. Has there been any translations? Yep. This is going to move it 2 units to the left and 8 units down. We're going to look for any dilations. There's no number out front here, so there hasn't been yet. So there's no dilations. Then we're going to ask yourself, has it been reflected over the y-axis? And the answer is yes, because there's a negative right there. Now I'm also going to start sketching these graphs so you can kind of see what happens, and then you can also check them on your calculator. So my sentence is going to look like this. The graph of y equals x squared has been translated 2 units to the left, 8 units down, and then reflected over the y-axis. So guys, let's sketch this one as we go. We started with the graph of y equals x squared. We translated it 2 units to the left, so I'm over here now. And then we translated it 8 units down, so I'm right here. And then I reflected it over the y-axis. So right here's my point at 2, -8. And then it's a parabola opening upwards. So there's what that sketch would look like. I should have also did that on number 7. Number 7, though, just slides the graph down 4 units and then flips it. We'll sketch a graph on these as we go. Let's jump over to let's do number 10. my parent graph is going to be the graph of y equal x squared. Now there's a couple of different ways to do this one. Ask yourself first, has it been reflected over the x-axis? And in this case, the answer is no. Ask yourself, has there been any translations? There's no plus or minus within the grouping symbol, so it's going to go over 0 units, but it's going to go down 2. Now you can call this one two different ways. You got to be careful though. 4x quantity squared really simplifies to be 16x squared. So you could say one thing, that this has been vertically stretched by a factor of 16. If you want to leave it as 4x quantity squared, you could also say that it's been horizontally compressed by a factor of 16. They both mean the same thing. And then ask yourself, if it's been reflected over the y-axis, that would mean that 4 would have to be negative, and in this case, no. So my sentence will look like this. And guys, just pause the video if I get clicking a little too fast for you. The graph of y equal x squared, and just go down that checklist now. Just go straight down that checklist. Has been translated 2 units down and horizontally compressed by a factor of 16, or vertically stretched by a factor of 16. So just remember on that one, we could simplify first. To be truthful, what's easiest is always the vertically stretched or vertically compressed, that number out front. So the easiest way was to simplify that first and just see that it's been vertically stretched, made skinnier. Next one I'll do is number 11. Like I said, just pause if I get going too fast. You can write that sentence down. Here's our number 11. We got 1, 2, 3, 4. We ask ourselves if it's been reflected over the x-axis. And the function that we're talking about is the function 1 over x, that hyperbola that we looked at to start. It hasn't been reflected over the x-axis because there's no negative out front. It's been translated 2 units to the right and 6 up. There's no number other than that 1, and there's no number in front of that x, so there's no dilations. So this one has only been translated 2 units to the left, 2 units to the right, and 6 units up. It means our graph, instead of looking like this, will now be, there'll be a vertical asymptote at 2 and at 6, and it'll now look something like that. The sentence will look like this. The graph of y equal 1 over x has been translated 2 units right and 6 units up. Next one I'm going to do is number 12. So here goes. Ask yourself first if it's been reflected over the x-axis, and our parent graph, of course, is y equal x squared. Now in this case, it has been reflected over the x-axis. Look for any translations. So it's going to go 5 units to the right, 3 units up. There's a 2 out there. Now guys, remember, you have already taken care of the negative. We took care of the negative with this reflection. So only focus on the 2 now. This graph is going to be vertically stretched by a factor of 2. and then we look for any reflections over the y-axis, and there's no negative with that x, so the answer is no. So this one's been reflected, translated, and vertically stretched. Just go down that pecking order on our sentence then. The graph of y equal x squared has been reflected over the x-axis, so I've taken care of that. Translated, 5 units right, 3 units up. And vertically stretched by a factor of 2. And guys, as we go, I don't mind if you capital V, capital S for vertically stretched times 2. Now, the graph of this, let's get that going. We're going to take our original parabola and we're going to reflect it over the x-axis first, so it would be right there now. And then we're going to translate it 5 units to the right, 3 units up, so now I'm setting right there. I'm setting right there at 5, 3. And I'm going to make it a little bit skinnier than it was. You could type that in and make sure you kind of got everything right. Let's go ahead and drop down to number 14. There's that answer to number 13. If you want to pause the video and write it down, make sure you can understand it. Here's my number 14. Number 14 looks like this. Has it been reflected over the x-axis? The answer is yes. So I've just used that negative. And the parent graph, of course, is y equal to square root of x. There's been a translation in here. 4 units to the right, 5 units up. This thing has been vertically compressed by a factor of 1/3. So made wider. Now there's no negative in front of that x, so it has not been reflected over the y-axis. So guys, my sentence then, the graph of y equal to square root of x has been reflected over the x-axis, translated 4 units right, and 5 units up, and vertically stretched, sorry about that, vertically compressed by a factor of 1/3. So guys, I think I'm going to stop there, not in the video, don't get that happy. I'm going to stop there. I'm not going to do any more because they're all that same thing. But I do need to show you how to go the other way. If you're given the information, can you put it in an equation? So, if you'd like, you can pause the video because I have done the rest of them. You know, now that I say that, let's talk about number 16 real fast. Because when you just look at that, you'd like to say it's been translated 8 units to the left, but that's going to be wrong. What I need to do on number 16 is I've got that negative. To get your translation, your vertical shift, your horizontal shift, I need to make whatever's inside my grouping symbol say x plus or minus. So what I need to do is I need to factor out a 2 out of this. I'm going to factor out a 2, which leaves an x plus 4. And then I've got the plus 5. Notice that 2 times x is 2x, 2 times 4 is 8. But now, when we go to list these, it will look like this. I've got my 1, 2, 3, 4. It has been reflected over the x-axis with that negative out there. The translation is -4, 5. It has been horizontally compressed by a factor of 2. And there is no reflection over the y. But the key thing I wanted to pause and show you on that one, guys, is we got to factor that to get that translation. And of course, there's what your sentence would look like. The graph of the absolute value of x has been reflected over the x-axis, translated 4 units left and 5 units up, and then horizontally compressed by a factor of 2. Now, if you would, let's come over to number 18. You're going to be given some information, and then we're going to write the equation. So I'm going to go the same steps that we've been doing. Let's put a 1, 2, 3, 4, and let's go see if that information from that purple note card or that white piece of paper that you have is there. So it says the graph of y equal the absolute value of x has been translated 4 units to the right. Well, I know it's been translated 4 units to the right so far. Stretched vertically by a factor of 2. Vertically stretched by a factor of 2. Reflected over the x-axis. And then shifted 3 units down. Well, some things that I know now. If it's reflected over the x-axis, my a value must be negative. My h value must be 4. My k value must be -3. And my number out front must be a 2. So my equation is going to look like this. Y equal, there's a negative out there to make it reflect over the x. My parent function is the absolute value. I'm going to have an x plus 4, an x minus 4. That will make it go to the right. -3. And to vertically stretch it by a factor of 2, I need a 2 right there. So that's what that one looked like. Here's what your 19 is going to look like. I'm going to hit it the same way. 1, 2, 3, 4. Let's just read it and see what we can figure out. My parent function is y equal x squared. It's been shifted 3 units to the left. So part of my translation, 3 units to the left. Reflected over the y-axis. Shifted 2 units upwards. And vertically compressed by a factor of 2/3. So there must not be a negative out front. Well, let's put it all together now. We're going to have y equal, to get a translation, notice I left a little space. I got x plus 3 squared plus 2. That takes care of my translation. Been vertically compressed by a factor of 2/3, so let's put a 2/3 out there. And then to reflect it over the y-axis, I need a negative right there. Let's hit number 20 and then we'll shut it down. So here goes. Number 20. The graph of y equal x squared has been horizontally compressed by a factor of 25. Now, horizontally compressed by a factor of 25. So now, think about this though. To get 25 using a squared, I would need a 5. So it's really been horizontally compressed by a factor of 5. That way, when I put it inside the squared, I'll get 25. So got to be careful on that one. It's been reflected over the x-axis, so we know there's a negative out front. my translation is over left or right none, but up 9.9, and it does not look like it's been reflected over the y. So my equation is going to look something like this. Y equal, there's a negative out there to reflect it over the x, 5x squared plus 9.9. Or you could write it like this. So there'd be a couple of ways to write that one. So guys, good luck on your assignment. If you have any questions, get in and we'll get you straightened out. Otherwise, I'll get you straightened out next class also. Good luck to you.